This is Algebra 2 with trig. This is 3b.2a. We're going to add and subtract rational expressions. So here we have common denominators. They're both c. So we're just going to add the a plus the b. And we keep the common denominator. We don't say c plus c, which would be 2c. We just bring the c over. Same thing with subtraction. You're just going to take your number minus the other number. Here they're both variables, so we cannot combine them. It's just a minus b. And the common denominator for our case is just c. So there we subtracted two fractions. So now examples with some values in it. Because the denominators are the same, we don't have to do any special changing. We can just take the 3x and the 7. We're adding those two together with a common denominator that's exactly the same, 5x squared. Can I cross the x's out? I cannot cross the x's out because this is 3x plus 7. You can only cross out items that are multiples of each other.
Wait, so if it was 7x instead?
This is a binomial because we're adding two monomials together. We're not allowed to reduce just one side of a plus or a minus. You have to be able to cross the entire binomial out for you to reduce that. All right, on this side, our denominators are the same. So I know what my denominator is going to be. My numerator is going to be 9x cubed minus x squared. And at first sight, it seems to be the only thing we can do. But notice, this does come up occasionally. Yeah, you have to pay close attention. Sometimes you got to consider it and then find out if it's going to happen or not. What can I factor out of this top? X squared is in both of these. This one says x cubed, but that means there is an x squared in it. So if I pull the x squared out of both of those, this is going to leave me 9 with a x left over minus a place value holder of 1.
And then you can divide out the x squared, or the x at the bottom.
Our denominator is x plus 1. You cannot cross these x's out for the same reason we couldn't reduce over here, because this x is being added to the 1. But if this had been an x plus 1 some magical way, we could have reduced there. And you're going to see that in the future. But right now, nope, nothing can cross out. So by factoring it out was not super helpful. It didn't allow us to move forward anymore. But in the future, you might see some benefits from that. So let's come down and try to add our fractions together. Have an opinion. Don't just sit and watch. What's the top going to be? 10 plus 2 is 12. The bottom is our common denominator of 3x, not 6x. It's a common denominator. Now, you don't have any binomials. You don't have any pluses or minuses in between terms. So here you can reduce the 3 and the 12 to make a 4. So 4 over x is your correct answer. On this side, this one's going to be tricky because you're subtracting a binomial. More people are going to make mistakes here. So we need to be sure to subtract the 3x and also subtract the 3. So I'm going to have 4x minus 7 minus 3x minus 3. You need to distribute that negative into each of the terms of the polynomial that it's affecting. Your common denominator here is x minus 2. They're both the same. So I'm adding those. Oh, since we're subtracting, we need the common denominator. Now I collect our like terms. 4x minus 3x's, because those are like terms, gives me x. Negative 7 and negative 3 gives me 10, so negative 10. And x minus 2. Can I reduce the 10 and the 2? No, I cannot. You can't break apart just part of a binomial. You have to be able to cross the entire thing out. X's cannot reduce either, for the same reason. So you go ahead and try these two. Pause the video, work through these two, and then come back and I'll walk you through it. So our first example, we have 4 minus 1. 4 minus 1 is 3 over our common denominator, 3x squared. I see the 3 and the 3 on bottom. Those can be reduced. 3 over 3 is a value of 1. I have my x squared. It's left on bottom. So I have 1 over x squared. On this side, I have 2x squared plus the 2 over our common denominator of x squared plus 1. As usual, we cannot cross the x squareds out. But what can we do? Like I showed you up top, if there's something in here that can be factored out, it might benefit you in some cases. It didn't really help us here because nothing reduced. This could not be reduced. But this is going to have something that can be reduced. They both have a 2 in it. So I can pull the 2 out, and I would be left with an x squared. This is where you think about the rest. Plus 1. And my denominator is also x squared plus 1. Since the entire numerator, or not the entire numerator, but the entire factor is being crossed off, we're allowed to reduce it. Next, we have unlike denominators. These denominators are different. To add or subtract rational expressions with unlike denominators, we're going to find an LCD, least common denominator. So what we're going to see here, because they're letters, maybe it makes it more simple. The letters are different, so the only way that I can get a common denominator is by multiplying the two together. So I'm going to take my A over C, because that's what I start out with, and I'm going to multiply the top of the fraction by D and the bottom of the fraction by D. Kind of like we talked about in the beginning. That's going to give me A over D times, or AD times CD. And I'm adding that to B over D. And what am I going to multiply that by? C over C. You got to keep yourself engaged. So this is BC over, now you know that the multiplication, it doesn't matter if it's CD or DC, it's still a multiplication of the two numbers. So you can rewrite that as C times D. Now they're identical to each other. So when we add it, we get AD plus BC. all over CD. So we had to multiply each term by what they were missing so they became common denominators. And the same thing happens with subtraction. In subtraction, the denominators, this one needs a D, and for this one, the denominator needs a C. So when I multiply them together, I subtract, and now I have common denominators. So I can do the math of AD minus BC over the common denominator. Next, we're going to move on and try it with numbers. So there's two different ways we can do it. Using the rules that we did up here, you would say we're going to take our 1 over 6, and what are we going to multiply this fraction by? 4. So we're going to say 4 over 4. That's multiplying the 1/6 by 1, right? 4 over 4 is 1. When I multiply that, I get 4 over 24, which mathematically, that is still 1/6. You don't want to reduce it because that takes you right back to where you started from. So we took the original fraction. We noticed that this denominator didn't have the 4 in it, so we multiplied the 4 to the top and the bottom. Now we're going to do it again. We're going to take the 1/4. And what does that need to be multiplied by? 6 over 6. And that's going to give us 6 on top and 24 on bottom. You don't want to reduce it or you go back to what you started with. But now we have common denominators. So this becomes 10 over 24. And then now it's okay to reduce. 2 goes into both of them and we get 5 over 12. So this should make 5 over 12 when you add them together. But we don't see that when we just look at the numbers. This is not 2 over 10. That's a common mistake. It's 5 over 12 because we got common denominators. Now here's another way we could consider doing it. Do you see how we had to reduce? So if I take 1 over 6, what do 4 and 6 both go into? They, of course, both go into 24. Is there a smaller number, a least common denominator? 12. They both go into 12. That is your least common denominator. Different ways that we could find least common denominators. The factor of 6 is 2 times 3. The factors of 4 are 2 times 2. And that's not working out for me. Those factors are 6. These factors are... So they both would need a 3. They both would need the 2. So 2 times 2 times our 3 is going to make our 12. We'll talk about that more tomorrow. So what's it going to take for the 6 to become a 12? We only had to multiply it by the 2. And what does it take the 4 to become a 12? So this becomes 2 over 12 and 3 over 12, which is now 5 over 12, which gives us the same thing. We got the same answer doing it either way. Notice it took us a little front thinking about what is our least common denominator. But then we went right through and multiplied it out. On this side, we didn't have to think so much until we reduced it. Then we had to think about what do we have to multiply by or divide by into each term to reduce it. Here we didn't reduce our answer like we did on the left. Now we're going to try working with polynomials. All right. So what we're first going to do is find an LCD. And then we're going to look at each term and multiply its numerator and denominator by what's missing. So what I'd rather say here, rather than say find the LCD, we're going to say factor the denominator. Factor the denominator. That's really the first thing you need to do. That helps you determine what your common denominator is going to be. Then we're going to rewrite each simplified numerator over what we figure out to be our least common denominator. We're going to distribute in the numerator. So we're going to combine the numerators together so we can collect like terms. But in the denominator, we're going to leave denominator in factored form. We're not going to combine those. So let's come on over here and try it. So the first thing we're going to do is factor our denominator. So we have 3 on top. Now usually we don't think about breaking a 10 up into 2 times 5, but right now that might be beneficial for you to think about. We have 2x on top. And how can we factor this apart? Everyone should have an opinion. We take a 5x out, and that leaves us with an x minus 2. So we have factored the denominator. Now we have to recognize what is each term missing. What's not making them exactly the same? They both have a 5. They both have some sort of x. This is x to the first power. This is x squared. So this side actually needs to be an x squared. We don't want to do multiplying to figure that part out. We just need an extra x. So it needs a 2. It needs an x. What does this side need? What does it not have with it? Very clearly. It doesn't have an x minus 2 with it. Some people get confused and they think, well, it has a 2. But no, that's going to be a separate 2. That's not a binomial type of 2. That's not in parentheses. This is multiplying the 5. This x minus 2 is kind of a separate term. So this fraction, 5 and 2 make 10x squared. We're going to do our x minus 2 to the top and the bottom, because that's what it was missing. This is 2x, 5x, x minus 2. What else do I need to include on this side to make them exactly the same? What is this missing? We talked about it earlier. So by multiplying 2x to the top and the bottom, that's taking this fraction, which was the original fraction, and multiplying it by a value of 1. So we're going to make it look different, but it's still going to essentially be the same value because we're only multiplying it to a value of 1. This numerator is going to be 3x minus 6. This numerator is going to become 4x squared. And I don't need to write the denominator separately because we've worked on making them the same. They're both going to be 10. They're both going to have an x squared. X times x is x squared. And they both have an x minus 2. So you would probably want to rewrite this so the polynomial was in standard position, standard form. Where the 4x squared was first, the 3x was second, and the constant number was last. Questions about that? What do you notice? What seems weird? This is where you would ask your questions. Okay, let's come over here to the second one. What's the first thing we do? So we all know. First, we're going to factor our denominator, which is x. That's our numerator. Our denominator has a common 3 in both terms. That becomes 3 times x minus 5. Here, the denominator is x and x. I need two numbers that multiply to be 5. Well, that's only one way to multiply to be 5, 1 and 5. So I don't have to be concerned about that. To add to be negative 4, the 5 has to be negative and the 1 has to be positive. Now, a lot of times we don't consider factoring this apart. But notice what happens when we do. This has a 2 in it. This is x plus 1. So these are two factors that are the same. By removing the two factors that are the same, you are simplifying this problem greatly. You may find that when you're working on your homework, if you're getting answers that are x cubed and you're getting polynomials that are hard to work with, you probably miss somewhere where you could reduce. This would be a spot where you could pull the 2 out and we could reduce our fraction down. So now we have x 3 times x minus 5, and this is 2 over x minus 5.
3 times both sides of the
This fraction needs the 3 on the top and the bottom. Good job. This one would be all set then. It has the x minus 5 just like that guy. It has the 3. So this is x and 3x minus 5. This is going to be 6 minus, so a negative 6. I wrote it just as one denominator. You might like that more in the center. It's kind of bugging me sitting off there to the side. 3x minus 5. That looks a little nicer maybe. And nothing can reduce. You cannot reduce the 3 and the 6. The 6 is next to a minus sign. So now these are left here for you to try. Our last two problems. You go ahead and work through these. Pause the video, work through them, then I'll come back and work through them with you. Here we go. This one's very similar to what we did up here. The only thing that's different is our one sign. So it should give you some confidence. So I noticed walking around that several of you had factored apart your 10 like we talked about. What that does starts to allow to show you what are you missing. What's the same? 5s are the same. I don't have a 2 over here. This is an x. This is x times x. It's x squared. So this is missing the 2x for the top and the bottom. I have to multiply this fraction by a value of 1 because my denominators eventually have to be exactly the same. This one, they both have 2's now. They both have 5's. This is x squared, which is x times x. This will have x times x. This is missing the x plus 1 and the x plus 1. So this is going to become 6x plus 6. Over here, this is going to become 4x squared. And my common denominator is 10x squared, x plus 1. You might rewrite it in order of the largest exponent down to the smallest, 10x squared, x plus 1. What I do notice here, and maybe we could have figured it out up here somewhere, you see there's a multiple of 2 in each one of those? And there's a multiple of 2 sitting in here. We could have done some reducing. Look at that. That this is 2 times 3, so we could have crossed those 2's out. We never needed it. So our best answer is going to be 2x squared plus 3x plus 3 and 5x squared, x plus 1. I didn't notice that situation here, but that did occur in this one. I had a multiple of 2 that could be factored out of this. I had a multiple of 2 down in my denominator. I could factor that out because these are all multiplying each other. Let's try our last one.
In that last...
All right, this side. We have our x minus 3 on top. We have our 4x minus 1. A minus makes the problem harder. You got to really pay attention to distributing it correctly. So this is going to leave us a negative 5x minus 2. You can consider factoring a negative out of there, but that's not going to help match anything down here. So no need to do that. X and x, 2 and 1. It's got to be a negative 2 and a negative 1 to add to be negative 3 and multiplies to be 2. So that's our factoring. I'm using a guess and check more method rather than a process to factor these. We want to start to move towards that. Now, what's our denominators? What are we missing? This doesn't have x minus 2. This doesn't have a 4. Otherwise, they both have x minus 1. Now they both have x minus 2. And they both have the multiple of 4. So that's our common denominator. So we're going to FOIL this together to get x squared minus 5x plus 6. That's what comes from that. Minus negative 20x minus 8. Notice how I used parentheses because I was multiplying it only into the negative 5x and the minus 2. I wasn't taking this negative into account. My common denominator is 4, x minus 1, x minus 2. Now I need to collect like terms. You're going to need to distribute your negative. This is where the mistake will come in. We're all going to call that a positive 20x, but you also need to call that a positive 8. So by collecting our like terms, we have x squared plus 15x plus 14, and 4x minus 1 x minus 2. Whew.